Okay, so we have a particle moves along the y-axis so that its position at time t between 0 and 20 is given by y of t is equal to 5t minus t squared over 3. Okay? And the question is saying, at what time does the particle change direction? How do I know that? How do I know when a particle changes direction?
The change of the inflection point.
The changing in direction is when the particle changes the direction of its velocity.
Yeah.
So when the particle changes velocity, Christopher, or changes the direction of its velocity vector, that is when the particle is changing direction. Okay, so what we have to do here is we have to find the velocity vector. And what's the velocity vector in terms of the position vector?
Derivative.
It's the derivative, so I have to take the derivative of this. So Vt is equal to dy over dt, which is equal 5 minus 2t over 3. Okay? Now, how will I know when the particle will switch direction?
When it goes from negative to positive.
Right. So that means I have to find the critical point, and I have to do the first derivative test, because the derivative test applies to the velocity, and that will enable me to know where the velocity is positive and where the velocity is negative.
Okay.
So if I do that, so I set this equals 0 to solve it, and then so we get 2t over 3 equals 5, and then if you solve this, you multiply both sides by 3, so you get 2t equals 15, so that means t equals 15 over 2.
Is that the answer?
Somewhat the answer, because first you have to make sure that it actually switches. So you take that and you do the first derivative test. You put it on the line and you do the first derivative test on the velocity or on v. Okay? So you pick a number that is less than 15 over 2 as long as it's greater than 0, because we're in between 0 and 20. And you plug it into the derivative, which is the velocity. So if I pick, say, 1, and I plug it in, I get 5 minus 2/3, which is positive. And if I pick a number greater than 15 over 2, say I pick 15 over 2 is 7.5, say I pick 8, and plug in 8, you get 16 over 3, which is greater than 5, so 5 minus something greater than 5 will give you negative. So that means the particle was moving in the positive direction here, and then at 15 over 2 it switched and changed direction, and it's moving in the negative direction. So yes, the answer will be 15 over 2, the particle changes direction.
Okay.
Okay?
Yep.
Okay, let's go to 8. If f of x equals...
Wait, weren't we just on number 4?
Oh yeah, I don't know why my test went to 8. Oh, I have to go to the other side. Oh, okay, got you. Sorry about that. So I'll adjust here. So I'll put 5. Okay? So question number 5, it's saying, find the average value y equals x cubed x to the 4 minus 1 on the interval 1, 3. Do you know what the average value is?
Give me a second, I need to get to
Huh? There's a formula for the average value where it says 1 over b minus a, the integral of f of x dx from a to b. That's the formula for the average value. So you're basically, what you're doing is you're taking the function, which in this case, by the way, is y, you're integrating it, okay, to figure out the area underneath it, between a and b, and then divide by b minus a, which is the width of that area, and that will get you the average value of the integral. Okay, so if I do that, so now this, so if I apply this here, what's my a and b?
1 and 3. So
1 and 3, so 3 minus 1. The integral from 1 to 3, they go a, b in order. X cubed, x to the 4 minus 1 dx. And now, how do I figure out, how do I integrate this?
this is the substitution.
Yeah, I use substitution. It's very simple. What will be my u?
X to the 3.
If you call u to be x to the 3, what will you do with x to the 4 minus 1?
Oh wait, sorry, the derivative of x to the 4 minus 1 is just 3x to the 3. So, okay, yeah.
Right. So because of what you just said, this guy has to be the u.
Okay.
So u equals x to the 4 minus 1, because the derivative of that will give me a constant multiple that is available inside my integrand.
Yeah.
So du is equal to 4x cubed dx. That means what? That means du over 4 is equal to x cubed dx. So now I could replace my x cubed dx with du over 4, and I could replace this guy here without the square root. I didn't mean to include the square root, right? Without the square root, just this guy here with u, right?
Yeah, okay.
Okay, so now this becomes 1/2, because 3 minus 1 is 2, okay? X cubed d, or this becomes u square root u, because I have a square root above it, to the half, which is okay because I can deal with that. I can integrate that. There's no problem with that square root. And then x cubed dx is just du over 4. And now because the 4 is a constant, I can pull it out in the integral, so this becomes 1 over 8 u to the half du. Okay? And what's the integral of u to the half? You add 1 and you divide by the new exponent. Okay? So this becomes 1 over 8 u to the 3/2. 1/2 plus 1 is 3/2. Instead of dividing by 3/2, you can multiply by 2/3. Okay?
Wait, 1, 8. Oh, go back up, sorry. 1, 8, 2, 0, 2.
Huh?
Where does the 2/3 come from?
This 2/3?
Yeah.
These these two add up to 3 halves. So instead of dividing this guy by 3 halves, I multiplied by 2/3. Okay. So then this becomes, now I'm going to put the u back for what it is. So we called the u to be x to the 4 minus 1. So now this is going to become, now I could simplify these two here by 4. So this is going to become 1 over 12. Okay. And u was x to the 4 minus 1. Okay. And this is raised to the 3 over 2. And now I will evaluate this from 1 to 3. Now, the 1 over 12 is a constant, so I will leave it out so I don't complicate my life with it. I'll come back to it at the end. And then I plug in the 3, so this becomes 3 to the 4. What's 3 to the 4? 81 minus 1 to the 3 over 2 minus, now I plug in the 1. Notice if I plug in the 1, 1 to the 4th is 1 minus 1 is 0. 0 to the 3 halves is 0. So this becomes 1 over 12. 81 minus 1 is 80. 80 to the 3 halves is the same thing as 80 cubed square root. Okay? Because the 2 is going to be the base of the integrand and the cube is on the 80 inside. So this becomes 1 over 12. Now 80 cubed is the same thing as 80 times 80 times 80. So 180 comes out. Right? And then there's 180 that stays inside the root. But 80 is the same thing as what? 16 times 5. Square root 16 is 4. So then this becomes 1 over 12. 4 times 80. Square root 5. And now if we reduce that, 4 and this guy reduces to 3. Right? So it becomes 80 root 5 over 3. There's no more simplification we can do because 3 does not divide 80.
Okay, cool. Excellent.
Okay, number 6. Okay, what does the question read?
Given that f is the continuous function of the interval 1 to 5, and f takes values shown on the table, the function f will have 2 zeros in the interval 1 5 with k equals.
Right. So 2 zeros, that means what? That means we can, if f is continuous on the graph 1 5, right? That means we can invoke the mean value theorem, right?
Okay.
To say that, because think about it, if we have a graph here, let me show you, right? And if x is 1, y is 4, so this is 1, 4. Oops, I meant to write 1, comma 4. So this here is 1, comma 4. And this point is 5, comma 3. So let's just say this is 5. Right? They're saying, what's the value of k such that the function will have 2 zeros? What does 2 zeros?
It will just be negative 1.
Right, it has to be negative 1, right? Because that's the only way where the graph is going to cross the x-axis.
When it says 2 zeros, it means when when the x-intercept is 0, right?
Yeah. So if it's negative 1, if point C is here, right? Because if it's anywhere else, if it's at 0, it doesn't work.
Okay, got it.
So it has to be at 3 negative values so that the graph will have the chance to cross the x-axis once, go down to where that negative value is, and then come back up and cross the x-axis again one more time to create that double zero that they're talking about, and then go back up to 5, 3. And the graph we know is continuous, so there's no breaks. Therefore, if that happens, it will have 2 zeros. 1, 2.
Okay.
Okay. Okay, 7.
Wait. Yeah, okay. So 7. If dy over dt is ky, k is not equal to 0, which of the following could be the equation of y?
Right. dy, wait, I lost the page. This thing, which one are we on? 7? Okay. So dy over dt equals ky. So this is a differential equation because you are given the derivative in terms of the variable, in terms of the dependent variable. Okay? In terms of y. So basically they're asking you to solve for y, right? Of course, yes. So what you have to do first, you have to move the y with the dy and move the dt on the other side. So you have to multiply by dt on both sides. So first you would get dy equals ky dt. Okay, and then you have to divide both sides by y. So this is called separation of variables in differential equations. So then you divide both sides by y and you get k dt. Okay, and now since you have the variables separated, in other words, the y and the dy separated from the dt, then you can integrate both sides.
Wait. dy equals ky dt is that you can divide both by y?
Yeah, I divided both sides by y. Yeah, I divided here by y and here by y. Here the y crosses out. Of course, you could divide by anything in math as long as it's not 0. Right?
Oh, okay, got it.
Yeah. Okay, so the integral of dy over y is what?
What is dy over y?
Dy over y is the differential of y divided by the equation y, the dependent variable, whatever it is. It's the derivative over the original.
Okay.
It's like we were integrating dx over x. It's the same thing.
Was the goal to get all the y on one side?
What's that?
Was the goal to get all the y onto one side?
Yes, the goal is to separate the variables on the same side. Yes, so to get the dy's with the y's and the dt's, if there's t's, the dt's with the t's. But there's no t's, so you just leave the dt on the other side by itself. Remember, k is a constant. It doesn't matter. It's like number 5. It doesn't matter where you have it. I could have it here or I could have it on the left. It doesn't contribute to anything. The point is to separate the y's and the t's with their corresponding differentials.
Okay.
Okay, so now if I integrate dy over y, the integral of that is ln y. Just like the integral of dx over x is ln x. And you can test, you can take the derivative of ln y and you're supposed to get what's inside your integrand, which you do. If you differentiate ln y, you get 1 over y. And here the k is a constant, I take it outside, and the integral of dt is just t. So this would be kt plus a constant of integration. Okay? So now, this is base e. So from the properties of the logs, I turn this around because I need to solve for y. All the answers are y equals this and that, not ln y. So now y equals e raised to the kt plus c, which is equal e raised to the kt times e to the c. Now what's e to the c? E to the c is just a constant, another constant. We can call it constant d. So then y equals de to the kt. And what's d? D is a constant of integration. That means if I'm given a set of initial conditions, I could solve for what d is. D could be anything. Okay? But this y equals de to the kt expresses a family, not a particular solution of differential equations, a family of solutions of the differential equations depending what d is, which I can solve for d. So the question is asking which of the following could be an equation for y. Well, if d is equal 95, then the solution will be 95e to the kt.
Why is e to the c on?
I mean e to the number 5. Isn't that like a constant? Some constant, say d, or e to the 6, or e to the 7. These are all constants.
Okay. Just by looking at it, b is the only one with e anyway, so that's the answer, right?
Right, right. Okay. Of course, another way to do this question, if you get stuck on the exam, is to take each, I mean, it wouldn't be very time efficient, but you can eliminate some of these fairly quickly, is to take the derivative of each one. Like, for example, let's say you are suspecting that the answer is A, right? Then a quick differentiation would tell you that dy, well, first of all, it's not, that doesn't even have a t, it doesn't make sense. Dy over dt is 0 for this, because there's no t here.
Oh, b is the only one that has t.
Right. So that's enough to tell you, but let's just say, for any reason, that, you know, it had, let's say this one was y equals kt minus 7. Well, a quick differentiation would tell you that dy over dt is equal to k. It doesn't equal ky. So that means it can't be the answer. Okay? Emails to you. And let me open a new page. Where's this mouse jumping, man?
Wait, what?
No, this mouse here is jumping on me for some reason. Okay. Oh, I think because this guy was there. Okay, number 8. Any questions on that?
Number 8?
Yeah, aren't we on number 8?
Yeah.
So f of x equals from 1 to x of t squared minus t square root dt. Okay, and the question is asking what's f prime of 3?
Isn't it just e because, well, wait, when can you use the fundamental theorem of calculus again?
Right, so this is a situation where you have to use the first part of the fundamental theorem of calculus, because you have a function in terms of the integral, and the question is asking you to figure out the derivative of that function. Right? So what is f prime of x? Let's find f prime of x. f prime of x is d over dx of this guy here, x, t squared minus t dt, and the derivative of an antiderivative is the function itself, because you are undoing the integral by taking the derivative.
Yeah, but is it only when it's from 1 to x, or how does that work?
Right, so I will show you. So basically what you have to do here, no, it doesn't have to be from 1 to x. It could be from any number to x. From any constant to x.
Okay, so that's the theorem?
Yes. So what you do is you go inside the integral and you replace that variable with your x. So this becomes x squared minus x. And then you use the chain rule to multiply this by the derivative of x, which is 1 in this case. Okay? So now to evaluate f prime of 3, all you do is you plug in 3. So this becomes 3 squared minus...
The lower bound. Does the lower bound not matter at all? Or
the lower bound does not matter, because when you take the derivative on that and you plug in 1, and then you take the derivative of that, you get 0. Because the derivative of 1 is 0.
Oh, okay.
That's why it doesn't matter. So this becomes 9 minus 3, which is square root 6. Okay? Now, let's assume that the upper bound wasn't x. Let's assume it was 3x squared. And you're taking the derivative of this. Then, you do the same thing, but then, so this becomes x squared minus x.
Oh, for t, you plug in 3x squared, don't you?
Huh? Oh yeah, sorry. That's what I meant. I was gonna put the t first. So you plug in 3x squared for t minus whatever that upper bound is, minus 3x squared. But then you use the chain rule to multiply by the derivative of 3x squared, which is 6x. Okay?
Okay.
So that's the idea, man.
Okay. Okay, so, yeah, I get this is all the fundamental theorem of calculus.
Right, right. This is the fundamental theorem of calculus. Yep. Okay.
Yeah.
Number 10. Okay, so f of x equals, oh, I mean 9, right? We're on number 9.
Yeah, we are on number 9, yes.
Okay. So f of x equals tan e to the 2x. Okay, this is f of x. And they want what? F double prime. Okay, how do I get f double prime?
It's just a chain rule.
Right, but first I have to get f prime, right? Because f double prime is the second derivative. So first I have to get the...
Secant squared x.
Right, but I have to find the first derivative first.
Yeah, but the first derivative would be...
Secant squared.
Huh?
Secant squared, and what goes inside?
E to 2x.
E to the 2x.
Multiplied by e to the 2x. Because that's the derivative inside.
Okay. Good. Chain rule to multiply by the derivative of the inside. And then the chain rule again to multiply by the derivative of the exponent of the inside. So times 2.
Oh, the chain rule within a chain rule.
Yep. Oh yeah. You could have as many chain rules as the problem allows.
Okay, so they're multiplied by 2, right?
Yes, multiplied by 2. I wrote 2 there.
Okay.
Because the derivative of 2x is 2.
So
Okay.
basically, A is the first derivative.
What do you say?
Answer A is the first derivative.
Answer A is the first derivative. Yes, they put it there so they confuse you. So if you're not paying attention and you find the first derivative, you just rush and put it as the answer, and of course it'll be the wrong answer. So they always do that because they want to see who's paying attention, who's being careful, who's done enough practice with derivatives to realize that those two dashes don't really mean the first derivative, but they mean the second derivative.
Yeah.
Okay, so now we'll do the second derivative. So f double prime of x. Now the story here is a little bit more involved because now I have this term has x in it and this term has x in it. And this too is a constant, so I will just leave it out and not mess with it. And at the end I will FOIL it in, okay, if needed.
Okay.
So now I need to use what rule here? Product rule, because
Just by looking at the answers, is it because that looks like the most complicated?
The most complicated answer does not always imply that it's the right answer. Because things, you could have a very complicated looking question, but then at the end of the day it simplifies to like one term. Like maybe it turns out to be 0, or I mean, I'm doing very complicated physics equations now, where the answer after 2-3 pages of derivation turns out to be 0. In mechanics. So that doesn't necessarily mean that. Okay, so let's apply the product rule. So on the product rule, it's the derivative of the first, which is the secant squared e to the 2x, which I have to use the power rule. So it's 2 secant e to the 2x, right? And then I have to take the derivative of secant, now the chain rule, to take the derivative of secant. What's the derivative of secant?
I don't remember.
The derivative of secant is minus cosecant cotangent, isn't it?
Is what? Sorry.
Sorry, I meant to say it's secant tangent. So secant x. Oops, not secant x. Secant whatever is in the inside. So secant e to the 2x, right? Times tangent e to the 2x. Now I have to use, remember this is just the derivative of secant. Now I have to use the chain rule again one more time to go inside the secant, which is the derivative of e to the 2x, which is e to the 2x, times, I have to do the chain rule a fourth time, or a third time, I think, to find the derivative of 2x, which is 2. Times the second, and the second is e to the 2x. So all I have to do is square this. Right? Because e to the 2x times e to the 2x is just e to the 2x squared. So this is the first part. Plus, because I'm doing the...
Wait, okay. So you took, I think, the power rule, right, first, and then the chain rule.
Right. I did the power rule first on the secant squared, and then I did the derivative of secant, which is secant tangent.
Okay.
And then I used the chain rule a second time to go inside the secant, which is e to the 2x, and then I used the chain rule.
Isn't the last one also 2 squared since you have two x's?
No, because remember that 2 I factored it out. I am not dealing with it. That last 2, that's here, I factored it out. It's not in my answer.
I mean, well, if secant, the derivative of secant squared is secant e to the 2x tangent e to the 2x.
Right.
2 x's.
because when you're doing the chain rule, you're not going on the secant and the tangent. You're going on the original, which is the secant squared e to the 2x. You're going inside the secant squared, not inside any of those bottom ones.
Oh, okay, never mind. Got it.
Because it's your original function that you're doing the chain rules on. These are just the result, the consequence of applying the chain rule.
Okay, then why is e to the 2x squared?
Oh, because I have e to the 2x coming from the chain rule on the secant squared when I did the chain rule of the inside. But then remember, the product rule says the derivative of the first, all this here was the first, and then e to the 2x was the second. So I have 2e to the 2x's. Okay, if this is confusing, let me just erase that too. Okay, all this here, all this that I put this thing under, this is all the derivative of secant squared e to the 2x times the second, which is e to the 2x.
Oh, okay.
So instead of writing e to the 2x twice, I was trying to put e to the 2x squared.
Okay, so then plus the second, plus the first after the derivative.
Right, so the first is just c secant squared e to the 2x. And the derivative of the second is just e to the 2x times 2 using the chain rule. Okay? So now f double prime equals. So now secant and secant, that's secant squared. Right? And on the second here I have secant squared, so I can factor out a secant squared e to the 2x. I could also factor out e to the 2x, correct? Because the first term has e to the 2x and the second term after the plus sign has e to the 2x.
Okay.
So times e to the 2x, this is inside the secant squared. And then I could also factor out the 2 because this has a 2 and this has a 2. So if I factor out the 2, this 2 here becomes... There's a 2 here, and then there's a 2 here. A 2 before the plus sign and a 2 after the plus sign. So if I factor a 2 out and I already have a 2 outside, this outside 2 becomes a 4. Okay, let's see what's remaining. Now, I already factored out secant squared, so I still have a 2 left because of this 2 here. And I have tangent e to the 2x. Okay? Right. So let me put the 2 in small here. And I also have an e to the 2x because I factored one of them out, but I still have another one remaining here.
Okay.
So this is e to the 2x. Plus, I already factored the secant squared out. I factored the 2 out and I factored e to the 2x out. So all I have left here is a 1. And so that would be answer E. Okay? Questions?
So when you factor secant squared x out, when you factor secant of e to the 2x, there's...
So let me show you what I factored out. I factored these two come up to secant squared, and here I have a secant squared. Okay, so I factored so this here is what I factored, secant squared out, and then, I mean they're both secant squared. Secant e to the x times secant e to the x will get you secant squared e to the 2x. Because secant times secant is secant squared. Right?
Oh, okay. I see.
And then here I have e to the 2x. And
I got that part.
And here I have e to the 2x, so I factored out e to the 2x.
Okay, I got it.
And here I have a 2, and here I have a 2. So I factored out this 2 here. When I multiplied it by 2, it became a 4.
Okay.
Yeah, because sine times sine is sine squared, as long as the inside is the same, right? And here the inside is the same. In both secants, it's e to the 2x. So secant e to the 2x times secant e to the 2x will be secant squared e to the 2x.
Yeah.
Okay?
Okay.
So let's pull the slide down. Okay, so which one are we on now? 10?
We are on... Yes, we're on 10.
Okay, so f of x equals secant 3x. And what's the question asking? F prime of 3 pi over 4 equals what? Okay, so that means I have to find the derivative and then evaluate it at 3 pi over 4. So this is a straightforward question. What's f prime of x? What's the derivative of secant? We just said secant tangent. So secant 3x times tangent 3x. And now you use the chain rule to multiply by the derivative of the inside. The inside is 3x and the derivative of 3x is 3.
Wait, so the derivative of secant is secant times tangent?
Yes, the derivative of secant is secant times tangent. You have to know that.
Okay.
There's a way to derive it if you don't know it. And I'd be happy to show you if you want, but it's just shorter to know what it is. Because on the test you may not have too much time for derivations because they're giving you a little bit over 2 minutes for each question.
Yeah, okay. So, okay, got that.
So this becomes 3 secant 3 pi over 4 times 3, right? Because I have a 3 here. Okay? Tangent three pi over 4 times 3. So 9 pi over 4. Right? Because 3 pi over 4 times 3 is 9 pi over 4. So I could just erase this here and make it a 9. Okay? Okay, so now the question becomes, what is secant 9 pi over 4 and what is tangent 9 pi over 4? And for this, you have to rely on your trig skills. So let's see what 9 pi over 4 is. Okay? If we make a unit circle here, okay? What is pi over 4? Pi over 4 is half pi over 2, right? So this is pi over 2, and this is 0, and this is pi.
And 45 degrees.
45 degrees. So if you go 9 times 45 degrees, because 9 pi over 4 is the same thing as 9 times pi over 4, right? So if you go 9 times pi over 4, so this is...
It's still 45 degrees.
Right, because you go twice in quadrant 1, twice in quadrant 2, twice in quadrant 3, and twice in quadrant 4. That's 4 times, that's 8 times, and then the 9th time will just bring you here. So now you're in quadrant 1.
60 plus 45, or is it just 45?
Just 45. Because you're back to the 45.
You don't count the 60 that you did?
You count, but your reference, the trig function for your reference angle is 45, and the trig function for the original angle is the same exact thing as the trig function of the reference angle. So I don't have to worry about the round, because as long as it brings you back to the same place, all you have to work with is your reference angle, which is 45. So if this is 90 and this is 45 and this is 45, so this is a 45, 45, 90 triangle. So as you know, this is 1, 1, root 2 is the ratio. Right?
Yeah.
And what's secant 45 or pi over 4? It's the huh?
Wait. Secant is 1 over sine, right?
1 over cosine.
No, 1 over cosine.
Right. So you take the cosine and you flip it. Cosine is adjacent over hypotenuse. So this will be hypotenuse over adjacent, which is root 2 over 1, which is root 2. This is the hypotenuse right here. Right? And this here is the adjacent to angle 45.
Okay.
So this is the secant, and now the tangent, we already have the triangle, so all we have to do is apply the formula for the tangent. So tangent pi over 4, because again the same argument applies. Tangent pi over 4 is the same thing as tangent 9 pi over 4, because the reference angle for 9 pi over 4 is pi over 4. So this
What
is,
angle are we using?
I am using this angle right here. Right here.
Okay.
It's always the angle with your terminal line and the x-axis. Always.
Okay.
Always. Okay, so that angle is, tangent is opposite over adjacent, so 1 over 1, which is 1. Because this here is your opposite to your angle. So now all you have to do is take these values and plug them in. So f prime of 3 pi over 4. So equals 3 times, we said it's root 2 times 1. So 3 root 2.
Okay. Is that the answer?
That's the final answer, yes. E. Okay.
Wait. Return. I think the answer is A.
A?
Oh, we're missing a negative sign somewhere.
Let me see. I could review. Derivative of secant is secant tangent. Right?
So currently secant of 3 pi over 4 is 3 times, so is negative rad 2. Why is that?
Let me think. Secant of 9 pi over 4 is negative.
Or in this case, it says 3 times. 3 secant 3 pi over 4. Why is it? How did you get 9 pi?
Let me see. I don't think so. But let me check.
Where did the 9 pi come from?
Because x is 3 pi over 4, so we multiplied 3 pi over 4 times 3. Because it's 3x, it's not x.
Oh, okay.
You're plugging in 3 pi over 4 for x. Let me see. So secant. No, they're wrong. They made a mistake. It's root 2. I did it on the calculator. I just did it here on the calculator. It can't be because we counted and we got the right quadrant.
Okay.
You understand?
Yeah.
Yeah. It's they made a typo.
Okay. Secant is 1 over cosine. And cosine is, the cosecant is 1 over sine.
Yes. Okay.
Okay.
Okay. So now let's go to 11. So in 11 they're saying f of x equals x cubed e to the x and e to the x over x cubed. Okay? And the question is saying what is the limit of f of x, so this is a limit question, as x goes to 1. Okay? So, what is the limit as x goes to 1? You could see that the function is a piecewise function, and the first one goes to 1 and it stops short of 1, and the other one starts a bit past 1. So that means the function
Like plug in 1, right? And see if it matches up.
right. So you have to find the sided limits. You have to find the limit as x goes to 1 minus and the limit as x goes to 1 plus. So let's do that. So I'm going to figure out the limit as x goes to 1 minus. 1 minus means a bit before you get to 1. So where do I plug it in? I plug it in on the first one because because this one doesn't go to 1, the first one. It stops short of 1, so this is e to the 1, so this just becomes e. And now I could find the limit of f of x as x goes to 1 plus meaning a bit past 1, and for that I plug it in the second one because this one goes a bit past 1, starts a bit past 1, and so this here is 1 cubed, so you get e. Are the two limits the same?
Yes, so it's e.
So therefore, since the two limits are the same, that means the limit exists at 1 and it's equal e.
Okay, cool. Right. Let's go to the next one.
Huh?
Okay.
Okay, this was 11? 12. Okay.
We're on 12 now.
F double prime of x equals x times x minus 2 times x plus 1 squared. Okay? Then the graph has points of inflection where? What does points of inflection imply? Points of inflection
When 0?
means the second derivative is equal to 0. So if we set the second derivative equals 0, what do we get? You set each one equals 0, so you get x equals 0, right? That's how you solve a polynomial, right? If it's factored, like it is here, it's completely factored, then you set each factor equals 0. So 0 and 2 and minus 1. Right? Now, does that mean at every single point of those you have a point of inflection? No, because this definition is not complete. It's f double prime equals 0 and the graph changes concavity. Okay, so now,
How do you test that?
Right, so now let's find out when the graph changes concavity. The way you do that is you do the second derivative test. So you take your critical points or potential inflection points from the second derivative, you put them on the number line from the lowest to the biggest, and then you test your the sign of your second derivative, and if it changes from minus to plus or plus to minus, anywhere it changes, then you have a point of inflection. Okay? So now, how do you test it? You just take a random point less than minus 1. So we have 3 regions to test, okay? We have here, 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 and here. So we take a point less than minus 1 and plug it in the second derivative. So if I pick minus 2, right? This is negative on the x. So if I pick minus 2, I get, so let's test it here. So we get negative times negative times negative, right? Because you get negative 2 times negative 4 times negative 1. So altogether it will be negative. You agree? Now we take a point between minus 1 and 0. Let's say minus 0.5. The first one will be, oops, wait, this was x plus 1 squared. I didn't see that. This is positive here. So that means this one here is positive. Okay, so now you take, I didn't go up far enough. Okay, so now we take a point between negative 1 and 0. So let's say negative 0.5. The first one is negative. The second one will be negative 0.5, negative 2, which will be negative 2.5, so negative. And the third one will be positive. Right?
Yeah.
So this will be what? Positive. Right?
Okay.
Now I will take a point at between 0 and 2, which is 1. So if I take 1, then the first one will be positive, the second one will be negative, and the third one will be positive. So that means positive, negative, positive. Remember, we're multiplying, so you get negative.
Yeah.
Okay, and then the third one, I take a point larger than 2, and plug it in. So let's say 3. So you get positive, positive, positive. So this is clearly positive. So that means what? That means here it's positive, so that means it's concave up, concave up. So here it didn't change concavity.
Yeah. Well, it's just 0 and 2.
Right. So, and here it's concave down and here it's concave up. So that means it's 0, 2 points of inflection. Okay?
Yeah.
So that means answer C. Okay? Let me email this to you. Okay, so now we are on 13. So 3x squared minus 4xy equals 1. And they said, when x equals 1, what is dy over dx? So what is this equation on? You're supposed to find the derivative. This is, and since the x and y are mingled together, this is implicit differentiation.
Okay.
This is implicit differentiation because these two guys here are together. Okay?
Yeah.
So I start by taking the derivative of 3x squared. So that's 6x minus 4. Now here, I have to apply the product rule on x and y because they're both variables and they both have derivatives. So the derivative of the first is 1 of x times the second times y plus the derivative, the first times the derivative of the second. What's the derivative of the second? Y prime, which is dy over dx, because this is the same exact thing as y prime. Okay? Equals, what's the derivative of 1? 0.
Okay. And then you have to move all the y prime to the other side, right?
Yeah, first I have to FOIL here. So this becomes 6x minus 4y minus 4xy prime equals 0. And then move the 4xy prime to the other side. So you get 4xy prime equals 6x minus 4y. Right? And then divide both sides by 4x. So you get y prime equals 6x minus 4y over 4x. I could divide each single one by 2 just to simplify it. So 3x minus 2y over 2x. And now I need to evaluate this as x equals 1. So I have to plug in x equals 1 here, right?
Yeah.
But what will I plug in for y? I don't know what y is, do I?
Can you just plug in y into the original equation? 1 into the original equation.
Right.
And I'll give you y.
That's exactly the plan. So that's exactly what you need to do. You need to plug in 1 in the original to find y. So if I do that before, so I get 3 minus 4y. I'm solving for y. Equals 1.
4y equals 1.
So that means 4y equals 2. So that means y equals half. So now I can find my y prime. So 3 times 1 minus 2 times half over 2 times 1. 2 times half is 1, so this becomes 3 minus 1 over 2, which is 2 over 2, which is 1. Which is the answer B. Okay? Straightforward question. Okay, 14.
Okay.
So if the curve is defined by f of x equals 1 minus x cosine x, an equation of the normal to the curve, so I need to find the equation of the normal to the curve at the point pi over 2, 1. Okay. Any ideas how I would do that?
You would have to find the tangent and then do the reciprocal.
Right, so basically if my curve looks like this, and let's say I'm finding the normal here at this point, right? That means what I need to do, I need to find the equation of the tangent line at this point, and the tangent line would be perpendicular to the normal. So this is the tangent line, and this is the normal here. Oh, sure. Where did my red disappear? Yeah. And this here is my normal line, right? So if I can find the slope of my tangent line, I can negative reciprocate it, and that would give me the slope of my normal line. And I have a point, so I can plug it in the point slope form equation and figure it out. So now the question is, how do I find the slope of my tangent line?
First off, let's see. I would plug in pi over 2. Wait, no. It gives you x and y already, so derivative?
The slope of the tangent line, Christopher, is the derivative. Is f prime of x evaluated at that point. Evaluated at x equals pi over 2. Very important. So, f prime of x equals, the derivative of 1 is 0. Okay? Minus, I will...
Oh wait, the derivative is the slope?
Yes, the derivative of a curve evaluated at a specific point gives you the slope of the tangent line at that point. Yes, of course. That's the definition behind the derivative. The derivative is the instantaneous rate of change, meaning it's the slope of the tangent line at that specific x.
Sorry, what?
The slope, the derivative of a function, is the slope of the tangent line at a particular x. That's the whole definition behind the derivative. It's the instantaneous rate of change. What's the instantaneous rate of change? The instantaneous rate of change is the rate of change at a specific point, which is rise over run, because it's the change in the y divided by the change in the x. As the change in the x becomes extremely small and approaches a specific point, in other words, the limit, as the change in x becomes 0. That is the definition of the derivative. And that gives you the slope of the tangent line, because the rise over the run is the slope. So to say it briefly, in sum, the derivative is the slope of a tangent line to the curve at that particular point. Okay? Hello?
Yeah, okay.
So now I have to figure out my derivative, and for that I will plug in, I will use the product rule on x cosine x, okay? I factored the minus sign so it doesn't bug me in the process, because I don't want to I wouldn't be confused. You wouldn't want to confuse yourself with a negative sign, so you just leave it out and then deal with x cosine x as a product rule. So the derivative of the first, which is the derivative of x, which is 1, times the second as is, times cosine x as is, plus the derivative of the second, which is negative sine x, so it becomes minus, plus minus becomes minus, sine x, times the first, which is x. So now, this is my derivative. I don't need to simplify here because that's not the point. The point is to find my slope. So I go ahead and plug my x in. So this becomes minus cosine pi over 2 minus pi over 2 sine pi over 2. Cosine pi over 2 is what?
1.
0. Because you're on top of the circle here. You're at 90 degrees. The x here is 0.
Cosine, it says cosine with x and sine is y.
Right. Cosine is x and sine is y. They go alphabetically. Cosine starts with a C, Sine starts with an S. Who comes first, the C or the S? The C. Therefore, who comes the first, the X or the Y? The X. So cosine associated with X and sine associated with Y alphabetically. So that's, you know, a good way to remember it. So sine pi over 2 is 1. So now minus minus becomes plus pi over 2. Okay? So that is the slope of my tangent line.
Okay, so now, wait, okay.
So what is the slope of my normal line?
2 over pi?
Huh? Negative 2 over pi. Negative 2 over pi.
Yeah.
Negative 2. Okay, so now what I'm going to do is you're familiar with the equation y minus y1 to find the equation of the tangent line equals mn times x minus x1. Okay, I'm finding the equation of my normal line. And I have the point. The point is pi over 2 comma 1. So this becomes y minus 1 equals mn, which I found to be minus 2 over pi, times x minus pi over 2. Yeah.
Okay, and then you would, if you wanted to, instead of using point slope form, how would you put it into standard form?
Without using the point slope form,
Yeah.
I could use the y equals mx plus b.
How could you do that? Oh, wait. How would you do that?
Huh?
How would you do it using y equals mx plus b?
Okay, so let me show. So y equals mn, right? The slope of the normal line plus b. I know what this is. I just found it. So this becomes y equals minus 2 over pi x plus b. And now I plug in the point.
Oh, for x and y, right? Okay, never mind. Got it.
Yeah. I plug in the point to find it.
Okay, and then x was, x is pi over 2. And then so that would be crossing out with that, so negative 1. So y is 1 equals negative 1 plus 2. The answer is D.
So okay, so now this becomes y equals minus 2 over pi, minus minus becomes 1, 2 over pi times pi over 2 is 1, and then you get another one from the other side, so plus 2. So this is the equation of the tangent. Okay? Minus 2, oh, I forgot the x. There's an x here, of course.
Okay, got it. Cool.
Okay?
Yep.
Any questions here?
No.
Okay, so yes, I emphasize very strongly that the derivative is the slope of the tangent line. This is very important. You will definitely be asked, if not many questions, at least one question on that. Okay, so 15. So we have f of x equals x plus 3 over x squared minus 1. And the question is asking, what is the instantaneous rate of change at x equals 3? What are they talking about? What do they mean by instantaneous rate of change? Do you know?
What is that? Instantaneous rate? Isn't that?
I just told you the definition 5 minutes ago.
Isn't that the limit as x goes to 0?
That is f prime, the instantaneous rate of change, the tangent line to the graph at a specific point. The immediate rate of change, these are all the same name for derivative. So they're basically asking for f prime of x.
Okay, then you just use the, you're using the quotient rule, so that'd be x squared minus 1 times 1.
Right, times 1, because the derivative of x is 1 and the derivative of 3 is 0.
And then there's the plus, or no, minus.
Minus
X plus 3 times 2x.
Right.
Over x squared minus 1 squared.
Right. So now all I have...
1 and 3, that'd be 9 minus 8. 8 minus 1, 6. 8 minus 36.
So 8 minus 6
that's 28.
times 6 is 36.
So that's 28, negative 28.
And this one here is 9 minus 1 is 8 squared is 64. Right?
So negative 28 over 64.
And you can simplify here by what?
Negative 1 over 3?
4. 4.
Okay,
4 will get you 7. And 4 will get you 16. So negative 7 over 16.
Okay. That
So,
will make sense.
answer B. You don't have to simple. See, the trick here with these questions is because you don't need the formal expression of the derivative since you're just plugging in x equals 3. You don't have to simplify this expression. There's no need. You just plug in the x immediately.
Yeah.
Okay. So let's go to the next one. So 16. If f of x is twice differentiable function on the interval a, x, and b, right? And f prime of x equals c, right? Then the question is saying, for everything between a and b, then the question is saying, what is f double prime of x dx from a to b?
Oh, how do we do this one?
Well,
Okay, just kidding. Wait, isn't the, okay, so the integral of the second derivative, wouldn't that just be the first derivative?
right.
So, then that would just be,
So that would be
0, c, right?
f prime, right? The integral of f double prime will be f prime of x, right? Evaluated from a to b, right? And what is f prime? F prime is c evaluated from a to b, Right, but okay, you see, look, when you, let me just show you one thing here. When you actually integrate this, right, you're gonna get f prime of x plus some constant c, right?
Yes.
And you know that f prime of x, according to the question, is equal some c.
Equals what? Yeah, equals C, yeah?
Equals c, right?
Yes.
Okay, and then you have to evaluate this from a to b.
Okay.
Okay, now if you plug in b, where do you plug in b? Where there's x, right?
Yeah, but there's no.
But there's no x, so it stays c on the first one. It's like saying integral of 5 from 1 to 2, there's no x, so it stays 5.
So it's C minus C, so the answer is 0?
So the answer is 0.
Oh, okay. Okay, I see.
Okay, 17. What does the question read?
If f(x) is continuous on the closed interval a, b, and differentiable on the open interval a, b, which of the following must be true? So
Right.
if f of a equals f of b, then some okay, what's a closed interval and what's an open interval?
Closed interval has, there's not much relevance here to that. They're just saying that it's continuous on that interval and it's differentiable. That means there's derivatives at every point except the ends. So this is just, you could take closed interval, meaning like it includes the endpoints. Open interval, it doesn't include the endpoints. The point here is that it's continuous and differentiable on AB.
Okay, well, isn't number 1 Rolle's theorem?
Right, number 1 is Rolle's theorem. That is correct.
Wait. Okay, well, yeah, okay. Then, so that is, so 1 is definitely right.
Right.
So then we can eliminate B and C.
Right.
And then if K is any number between, there's a, what does that little sign mean though? The C something.
That means C is in between. So that means C is in between A and B.
That's what C. If K is any number between, not sure. There's a value C between these, so I'm trying to see. Isn't number 3 the definition of derivative?
It's the definition of, yes, that means there's a value of C in between such that the derivative is equal to the average rate of change.
Intermediate value term.
Right.
Okay, so then I know 1 and 3 are right. I just don't know if 2 is right, so I would have to make a choice.
Well, think about it. If K is any number in between, wouldn't if C is a number in between, wouldn't the y of that function has to exist and it has to equal some definite value? I mean f of C, look, it's really straightforward. If you have a graph like this, right? And let's say this here is your A and this here is your B, right? And we know that this function is continuous and differentiable, right? And then K, if you have some value K here, what's f of K? If you have a value C, sorry. I meant to say C. If you have a value C here, what's f of C? F of C is this height, right? Wouldn't this have a definite value K? Some value K?
Yes.
And wouldn't the y value of K be in between this and this?
Between what?
Between, so let's say this here is 4 and this here is 8. What's the y value? Isn't k the y value? Isn't it between 4 and 8?
Yes.
Okay, but now let's take another scenario. What if the graph is like this? And this is here is 4, and this here is 3. And let's take a point in between. What's the value of k? It's not with it between 3 and 4, is it?
Okay, so it's no, right? Okay.
So, you understand?
Yeah, okay, it sounds like conversation. So 17 is T.
Right. Questions on that?
Wait. Apparently it says the answer is E. So 2 is right.
Oh, wait. Yeah, we misread the question. It's the other way around. They're saying if k is any value in between a and b, that makes c has to be in between them, yes.
Wait, if K is any number between F of K.
It's not the statement around the reverse statement is not true. If there's a value c between a and b, then there doesn't have to be a k between f of a and f of b such that f of c equals k. But the going forward is correct, yes.
Okay. Cool. Okay, so next problem.
Okay, hold on. Let me
Do you have any open time this week or no?
This week, yeah.
Like what?
I'll tell you what I have. I have Tuesday around 10 p.m. I have Wednesday around 10:30 p.m. I have Thursday at let me see. Thursday at around also like 10:15 p.m. or 10:30. Thursday could be up to 10:30 p.m. And Friday I have time in the day. I have Friday I have like 12 noon or 10 p.m. and Saturday I have time in the day at like 4 p.m. or after. I'm flexible Saturday.
Okay. Okay. If I need any extra help, I'll definitely contact you.
Okay, no problem.
Okay, so let's do the next one.
Okay, so which question were we on?
We are on problem 18, I believe.
18? Okay. So if f and g be differentiable functions, right, such that the first one doesn't equal 0 and g of 2 equals 3, and they are saying that h of x is equal to g of x over f of x, and h prime of x is minus g of x f prime of x divided by f of x squared. Okay? Hello?
Alright, and
Okay, so let's finish this one. Then they're asking for g of x. Okay? Right? So,
okay.
how do we go about doing that? All I have is the value of g.
Oh wait, F and G. Okay. Oh wait, didn't see this, but actually I have no idea.
Okay, so let's see. So we know that g of x is equal to f of x times h of x. Right?
Like why?
You just multiply both sides of the first one by f of x. Okay?
So back to the first. Oh,
Okay, but of course, none of those have the answer, right? So g of x will equal to, I don't know what that is, correct?
yeah, okay.
Um,
I'm sorry, doesn't Gx equal not f prime of x, just fx times hx?
yeah, that's what I wrote.
Okay, looks like f prime.
No, this is f here.
Okay, sorry.
And then on the second one, I know that g of x, if you turn this around, is equal to h prime of x times f prime of x. Oops, no. Okay, so h prime of x times f of x squared divided by f prime of x. Okay?
Like, so what did you do? You just plugged in.
Oh, and there's a minus sign here.
All you did was plug in hx, right?
What I did is I cross multiplied both the second equation, and then I divided both sides by f prime of x. Okay?
Wait, I'm sorry, can you kind of show how you did it?
Oh, this one here, the second equation is h prime of x times f of x squared equals minus g of x times f prime of x. And then I divided both sides by negative f prime of x.
You divide both sides by what?
By f prime of x.
Okay, okay, I see.
Okay.
By negative f prime x.
Yeah.
Okay, got it. Got it.
And so, oh, you know what? I apologize. I hate to rush, but my next student, I have a session and he's outside. He just texted me, so I gotta go open the door for him. But can we continue this next time if you don't mind?
Okay.
Okay. So I'll talk to you next week.
Okay.
Or whenever.
If I need you.
Yeah, whenever you contact me, yeah, just let me know. Just keep in mind that these spots that I gave you are available as of today, but they do fill up quickly. So especially it's AP week and stuff. So just keep that in mind.
Sure.
Okay, man. Take care. No? No? Hello? You ready? No?